When it comes to converting equations to the general graphing form, for any conic section, we're going to need to complete the square. If you think about the general graphing form of an ellipse, it has two things that are squared, two binomials squared. It has x minus h and it has y minus k. So we're going to need to get those using that method of complete the square. A couple of tricks to figure out if you have an ellipse from your equation is you know that both terms are squared. So here we have x squared and y squared. That's correct. The other thing about the ellipse that makes the equation stand out from one of a circle is that the coefficients on those squared terms are not the same. So this is true in this case. They're positive, which means this is an ellipse. So let's go ahead and find the equation for the specific ellipse by completing the square. Just like with circles, parabolas, anything else, we need to gather things together, organize our equation, and move things that have nothing to do with the variables to the other side. So I'm going to gather all my x terms. I know I'm going to add something. Then I'm going to gather all my y terms. Two plus somethings. Now I suppose you're wondering, why didn't you write your plus something for the y's? Well, we have to do an intermediate step with the y's. We are going to have to factor out that a, or that 4, before we can complete the square. It's okay, we remember how to do it. So we're going to really be completing the square for x squared plus 4x plus something plus 4 times y squared minus 6y plus something. And that's going to equal that 36 plus something plus something. So let's go ahead and complete the square. I'm going to start with my x terms here. b divided by 2, get me 2 inside the parentheses. Squared is 4, which means on the other side I'm going to add 4 to my 36. Now when we complete the square for our y's, we are going to have, don't forget that 4, y minus 3 squared is 9. So here's what we need to think about. We did not just add 9. We added 9 times 4, which is 36. So on that right-hand side, we have negative 36 plus 4 plus 36. When we add all those together, the 36's will cancel, and we just have 4. We're almost done with our equation, except remember, equations for ellipses always equal 1. So if we wanted the right-hand side to equal 1, what would we have to do? We would have to divide it by 4. And since this is the equation, we have to divide the whole thing by 4. So we're going to end up with x plus 2 squared divided by 4. Sorry, it's not writing well, and I'm running out of space. Equals, or plus, y minus 3 squared divided by 4 over 4 is 1 equals 1. So this tells me that this particular ellipse is going to be a horizontal ellipse because 4 is bigger than 1. We could figure out a lot more information about this ellipse now that we have it in the general graphing form. This is the reason we're converting at all. So let's look at another one where I have more space and then all my numbers won't get mixed up. And we'll practice completing the square and factoring out a couple more times. So looking at this equation, let's think about what tells us that we have an ellipse. Well, we have an x squared term and a y squared term. The coefficients are different and it's positive in between. So this means we do have an ellipse. So I'm going to gather all of my x terms together, gather all of my y terms together, move everything to the other side, and get ready to complete the square. So we have 3x squared minus 18x And then for our y terms, we have plus 2y squared and nothing else. This is kind of cool. This means that we don't have to complete the square for y. We only have to complete the square for x in this case. Equals negative 21. So let's complete the square for x. We still have to do at least that step. So we're going to have 3 times x squared minus 6x plus something plus 2y squared, which we don't have to do anything with, equals negative 21 plus something, because we only have to complete the square once. So we complete the square with our x term. We have to do b divided by 2 first. Squared is 9. But did you just add 9 to that side? We actually added 3 times 9, which is 27. Now our y's, we don't actually have to do anything. We have plus 2y squared equals negative 21 plus 27, which is 6. So we're almost ready with our equation. We just need it to equals 1. So look at the right-hand side. What would you need to divide 6 by in order to get 1? We would just divide by 6. To keep it balanced, you're going to divide the whole equation by 6. So we're going to start out with 3 over 6, which is 2. So we're going to have, or 1 over 2. So we're going to have x minus 3 squared over 2. My minus sign is messed up. There we go. Plus 2 over 6. That's going to get us 1/3. So we're going to have y squared over 3 equals 1. So now we have our general graphing form for this ellipse. We can see that this would be a vertical ellipse because the number under y is bigger. The center for this particular ellipse would be at 3, 0. When one of your centers is along one of the axes, you don't have to worry about completing the square for that variable. So that's the reason we didn't have to complete the square for y in this case. Alright, this is another one. See, I gave you all sorts of terms in this one. We have an x squared term and a y squared term, and their coefficients are different, so we know we have an ellipse this time. Let's gather all of our terms together. We're going to have an x squared and a negative 2x, then our y's together, plus 4y squared minus 16y equals negative 1. So now I'm going to get ready to complete the square. We'll get our plus somethings and we'll factor out our a's. So we get x squared minus 2x plus something. For our y's, we're going to have 4 times y squared minus 4y plus something equals negative 1 plus something plus something. We need 2 of them because we have 2 blanks on the left-hand side. So to complete the square with x, looks like we need to do b divided by 2. So we're going to get x minus 1. Squared is 1. Since we didn't need to worry about factoring anything out in this case, then we'll just go ahead and add a 1 over there. Now for our y terms, b divided by 2, which is negative 2. Squared is 4. But you did not just add 4. Remember, you added 4 times 4, which is 16. So that's going to go over on the right-hand side. Now let's simplify the right-hand side. Negative 1 plus 16, and we get 16 for our equals 2. One last thing we need to do, we need to make it equals 1. So we're going to divide both sides by 16. So we have x minus 1 squared over 16 plus 4 over 16 is just 1/4. So y minus 2 squared over 4 equals 1. So now we have our equation for this particular ellipse. And again, the reason we did this is look at all the information we can find now. We know the center, We know that it is a horizontal ellipse. We could find the vertices, the co-vertices, the foci. Once we have it in graphing form, the possibilities are endless. This is the last one we're going to look at. And again, we need to start out determining what conic section it is. So we have an x squared term and a y squared term. And because the coefficients are different, we know that we have an ellipse. So I'm going to gather all my x terms together and gather all my y terms together. 6x squared, that's the only x term, cool, that means no completing the square there, plus y squared, that's the only y term, another no complete the square, equals 6. Well, this is kind of cool. We're almost done. We don't have to complete the square on either one. That's okay. In fact, that's good, right? It saves you a lot of time. But you need to think about what graphing form looks like. Even if you're not needing to complete the square, you still want to get it into graphing form. And right now, we're not in graphing form yet. We need to get equals 1. So in this case, we'll have to divide everything by 6. So for our x's, we get 6 over 6, which is just 1. And I'm going to write x squared over 1 anyways. You don't have to, but I like to because that helps me see that important number underneath the x. Plus, looks like we're going to end up with just y squared over 6, nothing to cancel, equals 1. So now we have the equation for this ellipse. Now, yeah, we didn't complete the square between the first form and this form. However, look at how much easier it is to find information about this ellipse from the general graphing form. That's why we bother converting in the first place. Right now, we can say what the center is, we can say what the major axis is, the minor axis is, and we can use that information to find the foci. So the whole purpose of converting is to get it into a form that will help you find more information about that particular ellipse.